Welcome to Module 2 of the DevOps Foundation course. We're going to talk about core DevOps principles. So the first way is all about flow again, from development, code changes to deploy to operations. It's all about understanding all the different aspects of flow of work. This includes things like code check-ins, integrations, testing during integration, providing, obtaining a release candidate, and then going through the continuous delivery and continuous deployment stages, which include things like testing and preparing for deployment, and the deployment processes all involved in that, and trying to make it as smooth as possible, all those different things. You're trying to increase flow by understanding and removing constraints. So any one of those steps could become a bottleneck if you have, let's say, a manual process or something that is struggling to keep up. You generally don't want to pass a known defect downstream. You want to fix it as you go. But if it's a minor thing, I guess you could tag it as something to be fixed as part of your backlog. But in general, you're trying to avoid building a big backlog because that also causes bottlenecks. Usually you don't want local optimizations to cause global degradations. Now, that's not necessarily intuitive. In other words, you might have a super fast integration process, but a slow testing process. So that's not really going to result in good flow. You're just going to have a big bottleneck of testing. So you're trying to optimize the entire flow process from start to end and balance things. That requires having a profound understanding of the entire system, knowing how it all works and how it all flows from left to right. In general, the goal of the first way is to have work flowing quickly from left to right. This has a lot to do with the theory of constraints. It's a methodology for identifying the most important limiting factors, that is the constraint, that stands in the way of achieving the goal, which is flow, and then systematically improving that constraint until it's no longer a limiting factor. So that's kind of a methodology with the theory of constraints. You, first of all, look for where do you have a constraint, and if you've got other, areas in the stream that are going too fast, and you actually slow them down to try to make them match the constraint, and then you can improve the constraint and figure out how to get good flow going from improvements from that point. So the theory of constraints recognizes that every process has at least one constraint or bottleneck that affects its ability to consistently meet the goal. The process will only meet the capacity of its constraint and will only be as successful as its weakest link. Improving constraints is the fastest and most efficient way to improve the entire process or system. So first of all, identify where the constraints are and then balance things according to that constraint. And then you can make improvements from there. The theory of constraints was introduced in the book, The Goal by Elihu Goldratt, as Gene mentioned in the video. There are many kinds of constraints that you can identify. So there's a process of improvement. Identify the constraint, exploit the constraint. In other words, figure out what's the maximum you can get through that part in the process. Then subordinate and synchronize to the constraint. In other words, all the other steps, if need to be slowed down to match the constraint. Otherwise, all you've got is a lot of backlog and work in progress is waiting for that constraint. Then you can elevate the performance of the constraint. In other words, improve the constraint so that you can get more through that, and then repeat the process until you constantly are looking for what is the current constraint and then improve that constraint. That's the best way to go about it. So many different kinds of constraints can occur in this flow from development to production. Certainly development delays, where development is slow to produce changes, perhaps. Environment creation, this is a very typical one where there are many kinds of test environments, staging environments, production environments, setting them up, getting them working, matching the test requirements for the particular changes that are going through the flow, and then releasing them when you're finished. That can all take a lot of time. It's very frequently one of the main constraints. Code deployment, so getting code from the point where you think it's good enough to release and then actually getting a decision to deploy it can also be a constraint. Testing, set up and running. So even once you have the environment, you may have to, set up test suites and all the different parameters, and then run the tests, get the results. That can also be a constraint. In general, any security assessments after you've run security tests or QA tests, maybe that takes a long time just to analyze the results. Having overly tight architectures where you want to make a simple change somewhere in the architecture, but you have to, look at all the different dependencies across a complex architecture. That can also be a constraint. Product management itself and making decisions about what to do can be a constraint, and general complex or bureaucratic process. So these are just some typical examples of constraints. So let's just think about that for a moment. In an activity that's allocated 15 minutes for you to do some self-reflection on constraints. Or if you think about all those ones that we just went through, what might you do to overcome each of these types of constraints? If I were you, I'd stop the video right now and make some notes for yourself. And, what do you think you could do about these different things? Assuming you did that, I'll go through some of my own ideas, but these are by no means exhaustive ideas. So development delays, you might find that the problem is that development testing doesn't have a good setup. So maybe you have to automate testing and development, or maybe use test-driven development, or have some dedicated test environments, or more elastic test environments supported for the developers. Would be just one example. Environment creation, same sort of thing. Maybe during the different stages of testing, which can be integration testing, or the various kinds of testing, regression testing, system level testing, performance testing, acceptance testing, many different kinds of testing. So every one of those requires a test environment, and study that and figure out how can you accelerate setting up those tests and getting the tests running. Code development, deployment, looking at some of the different code deployment strategies like blue-green, canary, feature flag deployment. Some of the more sophisticated deployment strategies might help there. Test setup and run. Maybe you have a test harness that's not very efficient. You want to be able to mix and match the tests according to what code is being changed, and so that make that more efficient. Security and QA assessments. You maybe want to have the quality and security policies as code, so you can run through that without having to have a human, wait for the right human to do the assessment. Overly tight architectures. There, the typical solution would be to re-architect your application so that it's more loosely coupled. You don't have to change everything just to make a new feature. Product management, just in the manner that product management is operated, move more towards product, in fact, management rather than just project management, because a lot of the problems come in when you're looking at individual projects rather than looking at an overall product. So there's different strategies there. Bureaucratic processes, try to eliminate processes that are very manual, usually with policies as code, or even eliminating some processes that are not necessary. For example, let's say you have an audit process that requires you to stop and take data. So try to automate the data collection so that process doesn't get bogged down. So there's plenty of ways that you can overcome constraints. That's certainly just a small sample of the possibilities.